So next I'm going to use the same thing in the voltage divider circuit, how I'm going to compensate for VBE. In specifically in the old, this is second method. So I'm going to use the diode to compensate for the variation in collector current. So this is the voltage divider circuit. You know, you have VCC, you have collector resistance RC, you have emitter resistance RE, you have the potential divider R1, R2, and see here I'm going to place the diode in series with R2. I'm going to place the diode in series with R2. So this is the circuit which shows the diode compensation for an voltage divider bias circuit. Here the diode is connected in series with R2 and it is in forward bias condition. Diode is always forward bias because see here positive is connected to plus of VCC, negative is connected to minus of VCC. So diode is always forward biased. So I can write the emitter current as IE is equal to VE by RE. Ohm's law by Ohm's law, I is equal to V by R. In the emitter side, you see IE. This is my emitter current IE. So IE is equal to VE by RE. And what is VE? The total voltage VB minus VBE. See, total applied voltage is VB. It is split into VBE and VE. So VE will be equal to total voltage VB minus VBE. So IE is equal to VB minus VBE by RE. And mostly in transistors, we apply this approximation. IC will be approximately equal to IE, assuming that the base current is very, 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 very small. So wherever I use IE, I can replace that with IC without compromising on the logic that the base current flowing in the circuit is very, very small. Okay, so I can write this equation as IC is approximately